Yeah, okay. Ready to rock and roll. We'll do three examples in our notes. So today is the 17th of the 10th month, so that makes it officially 10/17. Make sure your Chromebooks are all closed and the cell phones are all put away, all that kind of stuff, right? So before I start with, I'll just tell you what we're doing today, by the way. I think I called it earlier, using equations to solve word problems. I think that people oftentimes are scared of word problems. I think that I hear that a lot from, I usually meet you guys, kids, young folks, when they're like 13 or 14. And around the time I meet them, a general consensus is like, well, word problems, yeah, they scare me. And I don't know where that comes from. Sometimes it comes from, things we've heard in our life or bad experiences we've had, but you shouldn't be scared. Can you guys shut the door, please? I don't know what's going on, but it's causing people to not be able to focus. Thank you. So anyways, I hope you leave today's lesson and feel like this isn't that bad. And the process that I'm going to give you today, the 4-step process, you can use it in not just like basic algebra problems, but in a lot of different applications. You can apply these 4 steps. And you might find sometimes that there are more steps than that. Like there used to be a poster over there, something about this problem solving process. I guess I got rid of it, but different people might tell you there are 5 steps or 6 steps, but I really believe in these 4. So I also want to say one more thing before we start. If at any time you feel like you can solve these mentally, just know that it's not going to get you very far. Like there might be problems along the way where you can look at them and say like, oh, I can figure that out easy. The numbers are like 25 and 32. You're just not going to get any gold stars for that. Okay. So in addition to wanting to find answers today, the purpose of today's lesson is to teach you a process. And even if you could have gotten the answer quicker by just doing some mental math, I'm telling you straight up, please do not. Okay, embrace the 4-step process. That's going to be huge. So what's going to happen today is I've got 3 examples. I'm going to type them up on the board and you'll copy them into your notes. I realize that I can probably type quicker than you can write. So I will be mindful of that and I'll give you some time to get these copied into your notes. So if you find a typo as I go, like earlier, I spelled and as a nad, which is kind of funny. I did NAD. So if you see me do that, you're welcome to point it out, or you can just obviously extrapolate from contextual clues what I meant to write. Either way, you won't hurt my feelings. I'm not the world's greatest typer. I've just learned how to do it out of necessity over the years. So the reason, like I said, that I'm re-recording this is because I felt like it was a good lesson earlier. I just don't feel like I really drove the point home about please follow exactly these steps. I'm going to be a little bit more bossy with that during this class. Now, as you're finishing writing, I would ask you this, and I never know if this question makes sense the way it does in my head, but if I went and found just a decent motivated 5th grader who had never done algebra or anything like that before, and I offered them a $50 bill to find the answer to this question, and all joking aside, like you can't Google, you can't put it into a math app, you can't have an adult help you. If I just put a relatively motivated 5th grader in a room and dangled a $50 bill and said you have 30 minutes, do you think they could figure it out? I believe the answer is yes. Some people would say, "Oh, I don't know how to do this," but I think a person that had some motivation would say, "I'm just going to guess numbers until they work." So, like, what's stopping me from saying, hey, the first number is 30? Great. Okay. So if the first number is 30, then the second number would be seven less than twice that. What's twice 30? What's seven less than that? 53. So I'd go, oh, that didn't work. And so, I'd probably be done long before the person came back. That kid would be done, excuse me, and say, like, I'm ready for my $50. So I want to reiterate again and again and again and again, this is not a guess and check process. There will be no attaboys, no stickers, no kind words issued for that. We're learning a process today. We could guess and check it. We're not going to. So step one of the four-step process is to declare your variables. And I'll show you what I mean by this. I'm going to say let x equal something, because we're going to turn this into an algebra problem. Making everything into algebra problems takes the guesswork out of everything. Your science teachers would tell you the same thing. Your upper level college teachers would tell you the same thing. If you can turn something into an algebra problem, the guesswork is gone. So here comes the weird question that I'll hit you with on every problem. When you read the first sentence, you don't have to read it out loud, but when you read the first sentence, which of the numbers is being discussed less? The second number or the first number? Definitely the first number. And this is hard. If you're not a good reader, then you're just like, just waiting for this to happen. You got to be a part of this mentally. The sentence clearly says the second number is blah, 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 blah than the first, right? So the sentence as written is clearly addressing the second number directly. Therefore, we want x to be the other one, the first number. And I hope, if you're wondering why, that you'll understand why we picked that one here in about a minute and a half. So to reiterate, whichever number is not being discussed, pick that one as your variable. So like if it said, Hunter is 5 years older than his brother. His brother's age would be the one that we pick for X, because we're talking about Hunter, not his brother. So whoever we pick should be the one that's being talked about the least. Now, I need your help. If we go back in time to like August or early September, you hated these assignments. Do you remember the assignments where it said like, there said a bunch of words and then you had to write the math thing that went with the words in the blank? So like if it said like the square of the sum of a number and 5, then you put like x plus, and you'd like turn it into math stuff. You have to do that now. So what I need your help with is this. I need your help with filling in this blank. We're going to say let blank equal the second number. And I don't want to pick a different variable because we're not into systems of two variable equations yet. I want this to be in terms of x. It's really important with this lesson, if you're just waiting for someone to show you what to write, that you not stroll through today like this. Think hard. Can someone write me a mathematical descriptor of the second number relative to the first? Like, for example, if I told you that the second number was 4 more than the first one, I would just write x plus 4. Take a shot. Setter?
Okay, so the second number is 7 less than 5.
I agree. So what does that mean for me? Like, I got to fill in this blank right here. How?
We should have 2x minus 7.
Yes. And if you just watch my pen real quick, good job, Sutter. 7 less than, you remember that? Twice the first number. Well played, Sutter. Good job. This is step one, and it's going to be expected of you on literally every word problem that we do. Step one is now complete. We have given an algebraic description to all of the players in our game. We have the first number defined. We have the second number defined. That is step one right there. Check it off your list of things to do. Step two is to write an equation. And so this part of the process, the step two of the process, is going to come from the sentence that I'm going to underline in blue. What does that mean? The sum of the numbers is 89. Put that in English for me, not some nonsense. What does it mean when two things have a sum of 89? What is that? It means that when I add them together, I'll get 89. So basically, I need to write an addition problem now that says that two things added together make 89. So something plus something equals 89. That's what a sum of 89 means. And I'm adding together. I mean, if you've been reading English and understanding English for as long as you have, you understand that this is simply a matter of taking the first number and adding it to the second number and understanding that they're what makes 89. So what's going to go right here in front of the plus sign? The first number is X. And I'm going to add to that the second number. And what is the second number? And that right there, that equation written in white is a representation of first number plus second number equals 89. That, and I will not move on until I'm sure you've all got it, but I did want to tell you that is step 2. So step 1 is tell the world, here are my variable values, and this is what they stand for. Step 2 is to write an equation, an algebraic equation. Do you have any questions as to where that white equation came from? Okay. Step 3 is the part that we're going to be really just smooth, like this won't ever be an issue, and that's just do the math, right? So step 3 is solve the equation. And this by now should be massively simple. So what would we do first? Add like terms. So specifically, the x's would make 3x. What would we do after that? Add 7 to both sides. Get rid of the -7. So we have 3x equals 96. What would we do after that? Divide by 3, giving us x equals 32. Now I need you to understand that that is step 3, but that is not the final step. This is a 4-step process. And the thing about this is that everything that you see on the television right now that I've written in red and white, no one asked me to do that. Ever. That's my creation. No one came into this and said, find x. X didn't even exist until we decided to introduce him and write an equation with him. So please understand that this is not the conclusion of the problem. This is merely the conclusion of us screwing around trying to figure out something about something. So I'm going to ask you now, we just found out that x is 32. Who cares, right? What is x? Don't say 32 because I know that. What is it? Sutter? It's the first number. And so I want to take a quick moment and say this. The first number is 32. And I know that it's the first number because it says so right up here where that yellow check mark is. Can always tell who doesn't do the red step well when you say, what is X? And they go, I don't know. Well, you know because you wrote it down. You know what it stands for. Now, how are we going to find the second number? There are multiple answers to this question. Steve?
Subtracted by 89.
Absolutely. And why not take the simplest approach possible? You know the numbers together add up to make 89, and you know one of them is 32. Guess what the other one is? 57. Now, I want to always go back and make sure at this point in time that I have read and understand what the question was. The question won't always be just find everything. Sometimes it'll be, how much would 3 of these cost? Or what's the difference between these? And so I'm going to scroll back up now and look, and it says right there, what are the numbers? So based on my logic, that's my answer, and that's what I'm going to put a big box around. I should see boxes around what you deem to be your final presentable answer to the world. How'd that go for you? So in case I didn't, which I didn't show you, this is step 4. Step 4 is answer the dang question. So again, what was step 1? Say it again. Step 1. Right. That's called a variable declaration. You got it, Kennedy. What's step 2? That means write an equation. What's step 3? Solve your dang equation. And what's step 4? answer the actual question, right? So we're going to practice again now. Okay, so that was 1 down, 2 to go. And that's the process that we're going to use. And this process will work for all difficulties. These word problems are going to get harder and harder throughout the week. But if you embrace the process, you're going to be fine. So here's our next one. Same thing. I'm going to type it. You write it. I'll give you a moment to get it into your notes. So together, a lookie and a mookie cost $336. A mookie costs 4 times as much as a lookie. How much would 2 mookies cost? Just again, I want to keep saying this so you don't think you're like pulling a fast one. Could we guess and check our way to success? Absolutely. It's just not going to get you very far in upper level mathematics. When systems or equations get tougher, it's like you don't want to go there. It's the process. This week's about the process. What's step 1? Nothing to see here, right? Business as usual. So what's step 1? Okay, good. Yeah, so the lights went out and they came back on. Okay, that was funny. Okay, so now I'll ask you again. What's step 1? I'm hearing a lot from Sutter today, but I would declare your variables, right? And so step 1 is to say to the world, I'm going to let x equal what? Now, how do we decide which one we want x to be? The one we know the least about, the one that's least talked about. Perfect way to say that, Julie. So when I read the sentence, and by the way, it's the second sentence in this case, a mookie costs blah, 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 than a lookie. Who are we talking less about? The lookie, right? And so x is going to equal the cost of a lookie. Do not get lazy and just put let x equal lookie, because that can mean the width of a lookie, the mass of a lookie, the volume of a lookie, the number of lookies found in Madagascar between 1996 and 2000. You want to be very specific when you declare a variable, cost of a lookie. Don't be ambiguous. Now, I need another one. I need to let something equal the other guy in the problem, and that is the cost of a mookie. Everything you need is in the problem. How much does a mookie cost? 4 times as much as a lookie, which makes it what? 4x. Very good. Step 1 is in the books. We have declared our variables. Excellent. It's on to step 2, which is to do what? Write an equation. Good. And this equation is going to come from the first sentence, which says together, a lookie and a mookie cost $336. What's that equation going to look like? X plus 4x. Perfecto. Cost of one plus the cost of the other equals 336. It says it straight up in sentence number 1. Step 1, check it off. Step 2, check it off. Step 3 is light work for us. Combine like terms, you get 5x's equals 336. Divide both sides by 5 and you get x equals 67.2. No one cares about our stupid x. You remember that as you go. You don't put a circle around this and like, look at me, I'm awesome. No one cares. No one asked us about x. We have to go back now and say, what is x? What is it? Contextual, please use the context. It says it right in our declaration. What is x? It's the cost of a lookie. So I want to go off to the side now and say a lookie costs $67.20. And I also want to go off to the side and say a mookie costs how much? Just before someone types it in and figures it out, so we're all clear, how are we calculating the cost of a mookie? Sutter?
4 times 50.
Right, we're taking and multiplying by 4 because that's what the variable declaration says to do. And what does that come out to be? I want to say it's like 268.80. Does that sound right? So step 1, we did it. We declared our variables. Step 2, we wrote an equation. Step 3, we did the math. Have we completed step 4? No. And this is where it's really important. You know, I have to scroll. You just have to move your eyeballs a little bit. But you look back up, we didn't even come close to answering the question yet. The question didn't ask us how much does each cost. The question is, how much would I have to pay for 2 mookies? So how are we going to figure that out? Plus itself, right? AKA times 2, right? So I'm going to just take the cost of a mookie, which is the 268.8. I'm going to double that bad boy. And then I'm going to write a sentence. I'm going to say something like 2 mookies would cost $537.60. I want to check my math there. That's what I'm going to put a box around. Remember, the box is something kind of special. It's reserved for, here it is. I've done all your work. I've done everything. I'm answering your question. Good, good. Uno más. Easy, right? We are not scared of word problems. You got to have that process, man. Keep those 4 steps tucked away. All right, they're huge. Oops, I was about to start writing and I want to type. This will be our last one. And then we will we'll at least do a couple problems from your homework assignment together just to get you rolling. The second of 2 films lasted 19 minutes less than twice as long as the first film. Together, the films are 254. I hope you leave here today feeling a little bit, actually at the end of this week, but especially today, I hope you feel like you're more mathematically powerful than you were before. These problems can be scary. I want you to feel confident, like, hey, I can do this. I can do this. So when I read the first sentence, which film am I talking less about, the first or the second? Definitely the first. The entire description is about the second film. So we're going to let X equal length of the first film. The first is the one that we know less about. And now we're going to write an algebraic description of the other one, in this case, the second film. And so I like to just get it ready like this, like let blank equal length of second film. Again, don't be ambiguous. Don't put let X equal first film, let whatever equals. We want to be specific. you just put first film, that can mean a lot of different things. So I need your help with the algebraic description of the second film. It's 19 minutes less than twice as long as the first. This is very similar to our first example. I know you've got it. Anybody else want to throw their hat in the ring? Yeah. 19 minutes less than, that's what that looks like, is the minus 19, twice as long as the first film. Step one, done. In the books. What's step two? Write an equation. And that's going to come from this sentence that I'll underline in blue right here. Together, the films are 254 minutes long. That's what I need to write an equation. What's that going to say? Beautiful. Step one, done. Step two, done. Step three, what should be massively light work for us in the middle of October. Combine like terms gives you 3x. Next step. Gives us 273. Next step. You get x equals 91. And again, how many people care about x equals 91? Exactly none of them, right? No one gives a rip. That's our baby. That's our creation. Now we have to take it back out of our little nerd world and put it back into the context of the problem. What did we just find? The length of the first film, right? So we want to write off here to the side something like length of first film is 91 minutes. And while we're here, let's also fill in the other one. Length of second film. And, you know, again, there's more than one way to do this. Like a very quick and intelligent answer to how can I find the other one is just subtract it from 254. For someone maybe who's a little bit more anxious or like gets nervous, just you can always take the one that you know. Like if you know x is 91, then you could just take 91 and plug it right in there. Don't know why you would in this case, but you could. But again, common sense says the movies together last 254 minutes. So just take the total of the two movies, subtract the 91 minutes for the one you know. What does that leave the second film to be? No. Say it. Yes, it's 163 minutes. Well done. So the first film is 91 minutes. The second film is 163. And again, that can be arrived at a couple of different ways. But if you know two things add up to make something and you know one of them, there's no easier way than just basic subtraction. So now I want to go back up and read the question so that I know where to put my box. And the question is only how long was the second film? So when I go to answer this question, I'm going to box up this part because that's my final presentable answer to the world. I'm not going to stop recording just because, but I probably will pause it while I hand this out. I'm going to give you the homework. I should stop calling it homework because I don't need you to do it at home. I'm going to give you the next assignment. I need you to get out a piece of notebook paper and wherever you do your homework, because you're going to have like a work page to go with the worksheet page. So I'm going to just quick pause the recording while I hand out papers. Thank God. Okay, so
Yeah.
So on your notebook paper, the first thing you're going to do is up at the top of it, you're going to write something like, this is work for assignment number 13. Sorry, my writing of the word assignment could not have been much worse. Let me try to do better. Okay, here we go. Oh, now it's better. All right. So now we know this is notebook paper, and here we go with problem one. Step one is to declare our variables. Who's going to be our x? Definitely the first, because the description given in problem 1 is all about the second number. So we're all in agreement that we're going to let x equal the first number. What is the second number going to be?
Um,
4 times the first. How will I write that, Andy? It's got to be algebraic stuff.
um,
Yes. Then let 4x equal the second number. Very good. I, for the record, don't care if you like that step, but that's a real non-negotiable with this guy. The variable declaration is huge, so just get used to it. Takes 15 seconds. You got this. Step 1 is done. Step 2, let's write an equation. And the equation in this case is going to come from the fact that their sum, the sum of these numbers is 50. What will this equation look like? Totally. Number plus other number equals 50. And then that's step 2. Step 3 is generally the quick and easy. Just do the dumb math, right? Put your x's together, you get 5x. Divide both sides by 5, you get 10. And again, no one cares about your stupid 10 and your stupid x, right? We want to take it back out now and answer. What did we just find? We did. And so we're going to state that the first number is 10. And you can use abbreviations like the 1ST for first, the pound sign for number, whatever, as long as it's communicative and clear. So the first number is 10. What's the second number? It's got to be 40 because it's 4 times the first. And then when you look at the question, it says find the numbers. So I believe that I can put a box around this because that's what I was asked to do. I'm done. Now you're going to go back to the worksheet. Now there's not a whole lot that goes onto the actual worksheet itself, but you're going to go find that answer in the box on the right. Do you see it? You got to look down a ways, but eventually you find it. It's 10 and 40 is the answer, and it's way down near the bottom. What letter's next to it? E. And of course, almost shouldn't have to say stuff like this, but I'll say it anyways. Since we did problem 1 and it went with the letter E, the bottom boxes, wherever you see the number 1, you're going to put a big letter E. How long should each one of these take? A couple minutes, maybe? Let's go to the next one. That's it. Number 1 is done. So you should all right now have a lot of work on your number 1 on your work page. And then on the worksheet itself, on the boxes that say 1, you should have the letter E. And we're on to problem number 2. Variable declaration. Who do we know less about, the smaller number or the larger number? Definitely the smaller. This entire description is written about the larger, so we'll pick the other guy. So we all, I hope, agree that we're going to let x equal the smaller number. Now I need to write an algebraic description for the other one. So I'm going to say let blank equal the larger number, and I'm going to go back and fill in that blank with whatever you tell me to do. It says the larger is 12 more than. If it was 12x, then it would be 12 times. I want it to be 12 more than the smaller, so it should be x plus 12. Remember, more than means to add on to. Step 1, done. So we're on to step 2. And what again is step 2? Write the equation. And the equation says that their sum is 84. So what's that going to look like? Good job, Kennedy. X plus 12 equals 84. Step 1 was to declare. Good job. Step 2 was to write. Good job, Kennedy. Step 3 is to do the math that we've practiced. So how many x's here do we get? 2x. What's the next step? Giving us 2x equals 72. The last step? X equals 36. So again, who cares about our x? Nobody. That's all this stuff on the board and your paper is our creation. No one asked us for any of that. So now we got to go back and say, okay, I better put this back into English to answer a question. What's 36? Right. So we can say smaller number is 36. And then larger number is what? It's got to be 12 more than the smaller one. Did I hear 48 from somewhere? Very good. Bless you. Now I want to look at the question and make sure that I've done, enough, not too much. I want to make sure I've answered the question specifically. And it says again, find the numbers. You'll notice that it's not always going to say that. Sometimes it'll be more specific, like find the first number or find the second. But in a case like this, since I was asked to find both, I have found both. You box that up. Now let's go back to the worksheet. Do you see the numbers 36 and 48? T. And since we just did problem 2, we're going to go find all the boxes that have a 2. And there's only one of them, and we're going to put a T in there. Would you like to do another one together? Sure. One more. You can ignore me if you like. Okay. I'll do one more. You can tune me out, put in your earbuds if you like. Okay. I won't take offense. No, like it wasn't being seriously. Like if you want to just do it on your own, tune me out. It's total. I get it. I seriously wasn't being passive aggressive. Number 3. Who do we know less about? Definitely the second number. The way that second sentence is phrased, it's describing a ton of stuff about the first number, but all relative to the second. So the second number is our guy. So we want to let x equal the second number. Before your stupid social media came and took over, do you guys know what we used to call this thing right here, this symbol? It's pound. Very good. I know the Twitter came along and ruined it, and everyone calls it a hashtag now. But yeah, it's a pound sign. So, and we use that to shorten the word number. Yeah. So you're welcome to use that abbreviation as you see fit. I need an algebraic description now for the first number because the second number is my x. Who's my first number? Good job. Yeah, you did. That was a good process. You said it and then you kind of caught yourself and mathed it. So great job. So we're going to let x minus 9 equal the first number. Well done. Step 1 is done. Step 2 is to do what again? Right. And again, they tell us that the sum is something, so we know that it's number plus other number equals 45. Is everybody seeing it? I think I'm getting the vibe like you get this. That's the first number. That's the second number. It's pretty clear that when I add them, I'm supposed to get 45. The problem says so. All right, let's do the math. Step 3 is to just math it up. Put your x's together. How many x's do you get? Next step. Add 9 to both sides, which gives us what? 54. And then you have to divide both sides by 2, giving you x equals 27. 27. Good. And again, no one cares about our stupid x, right? That's our thing. X is our thing. So let's go back now to the words, to the understanding, to the reading, the comprehension. Who did we just find? Good. So I can go off now to the side and say the second number is 27. And then I can go above it because I kind of feel like maybe they ought to be in order, but no one really cares. The first number is what? 9 less than him. What's 9 less than him? 18. And then you can always check it and just make sure, like, does anything seem out of place? And it seems like, I think we did it. They add together clearly to make 45 like they're supposed to. One of them is 9 less than the other. This looks good. And then you go back and make sure that you did what the problem asked. And again, at this early stage of the game, they're generally just going to ask you for both things. And there it is. So let's go find the, wow, George Jable's quick over there. Yep, exactly right. It's that 9th one down or 10th one down. It says S. So go down to where the box says 3, and there are 2 of them, and put an S in there. And that's that. That does not mean we're done. It means I'm done interacting with you. But you're going to try to get at least another problem or maybe 2 done today, and then we'll put them away, and we'll work on them some more tomorrow. Sound like a deal? All right.